We consider it as a great privilege to be a part of Texas Innovation Challenge 2015. Emerging technologies are making our lives simpler these days. With the introduction of mobile phones, life has changed rapidly. This is a dream of radio engineering. Mobile phones merge landline telephone systems. These days, many advancements in the mobile phones are introduced. These advancements provide many services such as text, internet, etc. But although these are advancements in the technology, we still rely on the wired battery chargers. Each phone will have its own designed battery chargers. Thus, the battery chargers are required to carry everywhere to keep the battery backup. Now just think of wireless battery charger. Wireless mobile-to-mobile power transfer provides a convenient and easy way of charging at the time of emergency. The basic idea of this project is to transfer power from a mobile having high charge to a mobile having low charge without using any cables. Now let's move on to its block diagram. The voltage from the transmitter battery is given to the oscillator circuit. The oscillator circuit is connected to the piezo crystal. The oscillator circuit generates a square wave with frequency equal to the resonance frequency of the piezo crystal. Thus, the piezo crystal starts to vibrate at the resonant frequency. These vibrations are captured by the piezo crystal on the receiver mobile, which then starts to vibrate at the same resonant frequency. At this frequency, which was found to be equal to 2.7 kHz, there is a maximum power transfer between the receiver crystal and the transmitter crystal. The voltage obtained from the receiver crystal is rectified and supplied to a buck booster converter. Output of the converter is fed back to the input through the Texas Instrument Controller IC MSP430. The feedback from the output is fed to the ADC and a PWM is generated at pin P1.6 of MSP430 IC, whose duty cycle varies in accordance with the ADC output. The PWM is then fed to the input of buck booster converter. MSP430 is programmed such that when the output signal is low, then the PWM duty cycle is high and the converter circuit boosts the signal and vice versa. The duty cycle of PWM signal is limited to 30% with the frequency set to 12 kHz. MSP430 is programmed with Texas Instrument Code Composer Studio and MSP430 Launchpad. Piezo crystal used here is of diameter 35 mm. Now let's check the sensor part. We have given a square wave using a signal generator to the transmitter piezo. This is the transmitter and the receiver piezo. By varying the frequency of the signal generator, we have found that at the frequency 2.7 kHz the resonance occurs and at this frequency the maximum reception takes place. What we hear is the piezo vibrating. Now we move on to the receiver part. This is the Texas IC MSP430. A PWM waveform of 12 kHz with the duty cycle limited to 30% is available at the pin P1.6. You can see in the CRO. Next comes the buck boost converter circuit, which has the output voltage either greater than or less than the input voltage. It is essentially a boost converter followed by the buck converter with a capacitor to couple the energy. A feedback from the output is given to the input of ADC. Output of ADC is used to generate the PWM. Duty cycle of the PWM is controlled by the IDC output. Now what we see is the PWM output. This is the output used to buck or boost the signal. This is the intermediate Darlington pair output. This is given as a switching signal to the buck boost converter. Here what we see is the final DC output voltage which is obtained across the capacitor and is given to the receiver battery. This is the transmitter battery. This is the transmitter piezo, receiver piezo, oscillator circuit, the receiver circuit. Received AC signal is rectified and the voltage across the capacitor is observed to be 2 to 4 volt. At resonance, the maximum power transmission takes place and using this power, we can charge the battery at the receiver side. As an indication, we have provided a LED that glows to indicate the power transfer.